now let's go on to the next problem, which will be a simulation of collecting baseball cards. Baseball cards. Okay, let's go on with our baseball card collector issue, and here it is. So now, when I was a child, I didn't collect baseball cards, but I knew many people who did, and I did play Little League for 3 years, so I wasn't foreign to baseball, but I just never got the bug, so to speak. So let's say you collect baseball cards, like Topps, and they're sold in packs of 10 that are characterized by overlapping sets. Now, if you don't know, a baseball card will feature a player. You'll have players, popular players on the cards, and what the kids try to do is they want to collect a complete set of players, but they're mixed up. The players are mixed up and they're not complete and they overlap. So, of course, from a marketing point of view, that encourages the child to buy more sets until they can get a complete set. They can get all the matching cards by buying more sets. So let's simulate this, and we'll have to put some parameters on it. Let's say we want a complete set of cards of 10 baseball players, and we'll represent them with this character vector. So here's our vector of the 10 players, and it's a character vector. Let's read it in, called cards. So there we go. And we can take a look at it, and you recognize some of these names, whether you're a baseball fan or not. So there's our 10 baseball players. And we're going to simulate this again using the sample function. The sample function's your friend with simulation. It's used a lot, and rightfully so. And note we're expanding the arguments. We're expanding the way we use the sample function. The sample function can take several arguments. The first one is the set from which you're sampling. The second argument is the number that you're sampling from the set. And you can sample with replacement or without replacement. The default is without. That is, if you don't stipulate replacement equals true, it will sample this number from the set, if there are enough, if you have at least 20 in the set, and it'll just simply rearrange them. It'll select one, take it out, withhold it, select a different one, take it out, withhold it. If you do it with replacement, it puts it back each time. So you can select the same one twice. Now, if the size that you're sampling is greater than your set, you must do it with replacement, or you get an error. You can't select 20 from a set of 10 unless you replace them with each selection. But the other thing that selecting with replacement does is it opens the possibility of choosing the same element more than once, which is similar to what we're doing here. So we say we're going to make some assumptions, and the assumptions will be this. We'll say the probability of selecting any one of these players is the same whether we're buying a set of 10. If we're buying a set of 10, each card in the set of 10 is an independent sample, and the possibility that each one is a particular person will be the same. So it doesn't matter if we're buying 10 at a time or one at a time. We'll say 20. We're going to buy 20. We'll say there are 2 packs of 10, but it really doesn't matter. Well, I guess it does actually, because you replace one with each selection. So you'd have to do this one at a time, but still it's a multiple of 10. Okay, so we're going to choose 20, and we're going to do it with our cards vector, right? Here are our list of players. Okay, so 10 players. If we sample 20, we've got to put them back. Okay, so let's do that. So, and we'll put the result in sample cards. So we do that, and then we take a look at sample cards. There it is. And we do have repeats. We have to, of course, with 10. But some are repeated more than just twice. There's DiMaggio once, twice, 3 times. Then we have Schmidt once, twice. You can see a lot of repeats. Okay. So rather than go through here, what we want to do, our objective now, is how many unique players did we get? Did we select? Did we get all 10? So rather than go through here and count, we'll get the computer. Computers are better at that than we are. We'll get the computer to determine the unique numbers, and there's a function that's called that. It's called unique, and it returns the number of unique matches. In fact, it returns the values. It returns the values of the unique matches. So if we run that on this set, we see there are 9. We have 9 unique players out of 10. We got 9 of them. So unique returns the unique values. Length returns the number. So if we embed all of this inside the length function, we get the number, which is 9.